Should just be Linux.
Oh, there we go. Is that the change?
And I've now turned the mic on, so we're going to now also have to wait for the delay until the audio comes through.
Okay, that's fine.
Yes, A3 is the roughest one.
We've already got the spec. All the tutors.
How much money do I need to pay?
A3 was the one that builds character. It builds.
Hey!
link fairly recently. And they have said that they will respond to us and allow us to get through their firewall in 1 to 2 business days, which I don't think is going to be particularly useful for anyone in this room. So, as a workaround, if you happen to have a hotspot that you could use, that would be huge. Otherwise, maybe recruit someone and see sort of a Python environment, which hopefully you guys all sort of have. You will be able to just sort of work with, but you won't have like the actual like notebooks that we have.
We'll
show everything up on the screen, like all of the code, but like the idea is that you log into this server and it's sort of all there for you. So if you're not logged in to that server, then you just sort of won't have it, but you'll be able to see everything. Yeah. So please let us know if you have any issues with that setup. I know it's a little bit janky, but apologies for that. I only tried to log in through the UQ system half an hour ago. Yeah, sick. So we'll give everyone a couple of minutes to sort of like try to like go to that link there and log in. And then if anyone has any issues with that, please let us know. And then hopefully once everyone's sort of got to a reasonable working environment, we can sort of kick off. Sick. Yeah, feel free to ask questions.
I don't know how to make that one. Picture in picture.
Like just to make sure. I don't know why she why like
Because they're
They're all like
Whose keyboard is it?
actually
You guys using a non-mechanical keyboard? That's
Yes, there is sound. Okay. Might just turn the sound off. Yeah.
got a system, who's actually managed to like log into this and like has all of our sort of notebooks and everything in front of them.
Actually, a better question, who hasn't
Who
managed?
hasn't? Well, okay, cool. Let's go around and we'll help a bit.
Who was? Sorry, I wasn't.
And those people who haven't done it, could you please re-raise your hands because I just didn't pay that much attention. Sorry.
Whoever goes and picks it up, he's standmates, right?
Awesome. So is anyone still experiencing any sort of technical difficulties, or are we good to sort of get going? Apologies about that slight hold up. I blame UQ for that. I blame the people who filter us. They're silencing us. Yeah, censorship, something. Cool. So, let's get on to what we're sort of going through today. So, basically, might start with a few quick intros from us. So, hello all, my name is Luke. I went to UQ and graduated as a software engineer, like a software engineering / maths degree in 2021. I was here for 6 years, so that was fun. I've been in those seats before. Then after that, I graduated and I started at IMC in February last year. We do like 7 weeks of dev school where you sort of get to go through all of the IMC systems. That's where I met Matt. And then following that, I joined the Python strategy team at IMC, which is quite like sort of a small section of IMC that focuses on basically what we're responsible for is that traders will come up with some sort of numbers that they think will be useful, that if they sort of see them, they'll be able to make trading decisions based off of them. And this is often based off a huge amount of historical data. So what my sort of team does is we'll look at 3 years of data, sort of process like some values across all of those 3 years, then look at what's currently in the market and compare how that compares to like the previous all of history. And then if these particular metrics are high or low, the traders might think that that is an opportunity to sort of trade. So that's kind of an idea, and I do that all with Python, and I shall hand it off to Matt.
Explain what IMC does.
Oh, IMC is a trading company. That's probably a good starting point. So we sort of trade on the stock market, and we're what's known as a high frequency trading firm. So that's basically the idea that you go and you buy something and you sell it for slightly more, and you do that really quickly. If something's worth $10 and you buy it for $9.99 and then you sell it for $10.01, a fraction of a second later, you have made 2 cents. But the thing that's really awesome about that is you no longer have any position. So it doesn't matter if you've gone through that process and you've made your 2 cents, and now this, you know, it's GameStop and it goes up or it crashes or whatever, you've got your 2 cents, you're out. And if you do that enough times, you sort of make some money. So that's the basic idea of what IMC does, and hopefully that provides some context for all of the things that I said before that. So
I guess I should probably also clarify, like the reason that like exchanges like us and why we're on exchanges is like we're classified as what's known as a market maker. So essentially, like from an exchange's perspective, if you want to go out and buy like a stock, like there needs to be somebody on the other side willing to sell it to you, right? So what exchanges want is they want tight markets where like somebody is like, okay, you know, no matter what, I'll be willing to sell this or I'll be willing to buy it from you. And so the idea there is that like if an exchange is really liquid and there's competition amongst other market makers, there'll always be like, you know, if it's some stock, some option, there'll be like somebody willing to buy it at like $10 and somebody willing to sell it at like $10.01. Like the idea is that like it makes it really like convenient for people who are coming to the exchange who actually want to buy those products if there's somebody always there on each side. Yeah. So my name is Matt. I went to UNSW Canberra, and like Luke said, I started with Luke at the same time, and I work in the strategy Delta 1 team. So Delta 1 is just like a class of products that we trade basically, and I do a lot of work in Java. So like the idea kind of what Luke does is a lot of like analysis and like long-term signals. It's like over 3 years. What we do is more like the slightly quicker kind of like pricing in the moment. Like, okay, like we have this feed coming in from the market. How do we like price these products so we're not like selling them for like a wildly wrong value, if that makes sense, right? Like we see like the market information, we need to know, okay, what is this worth? Like, should we buy it? Should we sell it? That sort of stuff.
Cool. Yeah, so I mean, basically this is going to run as sort of like a bit of a Python workshop that's a little bit similar to sort of some of the stuff I do in my day-to-day work. So that will sort of run for 2 hours. We've got a little bit of a quick intro to Python, just so everyone's got like a base level understanding of Python. And then more interesting, we'll jump into this library called Pandas, get some actual like sort of fake data and like have a look at it and try to sort of do some analysis on it. Yeah, I mean, why Pandas is it's basically just a really good sort of framework for getting in like lots of data and processing it. It's widely used across a lot of sort of industries and stuff like that, and it's very sort of easy to use in a lot of ways, which is why Python's really good, is that it's quite easy to use, and so you can sort of do sort of large data analysis quite easily. Yeah, so we'll sort of do that, and then following that, I believe I have heard that we have pizza. So I believe that's something that's coming up, and so when we get around to that, we'll get a chance to sort of like actually chat to you guys a bit more about sort of what we do and things like that. If you're interested, or if you just want to get some pizza, then I'm sure that you can just do that.
We won't hold it against you.
Yeah. Cool. So we'll start with this quick Python intro. And basically, the idea of this. So, a bit bigger. Okay, that's 1+1+, right? Oh,
Software engineer.
Software engineer. Let's go. Is that big enough? Sick. All right. Let me.
Also, please feel free to like put your hand up or yell out if like you have questions or you can't see something or you want anything clarified. Like,
yeah.
Please.
We want this to be as interactive as possible, which you can obviously tell by the fact from nobody is sitting in any of the front rows. That seems like a proper software engineering audience. Don't worry, I'd be back there too. Cool. So we've sort of got this quick intro that's just sort of running through a bunch of like the basics of Python. So a couple of things. Python's an interpreted language, as I'm sure a lot of you sort of know, which is basically the idea that we have something that goes through line by line, reads the code, and sort of processes it. That means that it's not going to be as quick as some of the compiled languages, but it is quite easy to use. We also get sort of we have that it's dynamically typed, which is basically the idea that I think if any of you have sort of experienced like Java and C, hello Siobhan. If you've experienced sort of Java and C, then they sort of have this really strong typing system where everything has strict types, and Python doesn't have that. The type checking is only done at runtime, which does cause some pretty fun problems sometimes. Yeah, and then it also uses indentation for program structure. Those of you that are familiar with sort of curly braces, the concept of that is that Python just does it with its indentation. So it essentially just forces you to have good coding practices. Yeah. So in terms of running Python, basically it's an interpreted language, and so we sort of run it with a thing that is called an interpreter, which is very exciting. A lot of the time you run Python in something that looks like this, where you just sort of call it with this Python guy, and that pretty much reads through your code and executes it. Instead of doing that today, we're going to be using something called Jupyter. Has anyone used Jupyter before? So there's a couple of hands in there, but it seems like not too many, so we'll spend a bit of time going through that. Has anyone not used Python before? Okay, so we're going to focus more on like the Jupyter stuff than the Python stuff then. So we can, thank you CSSE 1001. Cool. So in Jupyter, we basically have these ideas of code blocks, which we call cells, and you can rerun or run any of these cells at any point in time. And your Python interpreter maintains a state between the runs of these cells. So essentially, right, I think hopefully a lot of this like allocating variable stuff is stuff that you've seen before in Python. But we can run this by holding shift and pressing enter. And you'll see that this sort of thing here went from something to a 1. That basically means that it's looked through and it's run each line of these code.
Does everybody want to try and do that now in your own laptops just to make sure like you can run something?
Yep.
So the shortcut for that was just shift enter, or you can press the little play button that's like you can see up in the top.
Yeah, there's a little play button up here as well. Yeah.
Is everybody able to run a cell in Jupyter? Is anybody having problems running a cell in Jupyter?
Yeah. Alright. Cool.
We'll assume
Okay, we're going to assume, but feel free to ask questions at any point in time. So after this, once we've run this code, we sort of actually have this x, y, and z are actually stored in variables that are going to be maintained. So if now we look at the variable x and we shift enter on this new cell, we'll see that x has the value 1. So it's just this idea that we have this state and it's remembered between cells.
And so if you all want to try that, you can basically just click the plus button up on the top toolbar to add a new cell. And then you can try doing exactly what Luke has done, where you put an X in, and it should print out 1, which means that we've like already run that bit before and we've saved the state.
Yeah. Yeah. So, and you'll see that we have this code down here that will assign some variables to A and B. And if we try to run something with the variable A, you'll see that it freaks out because A hasn't been run yet. But you can run sort of things in and out of order, which can sometimes cause some issues if you sort of run things in an order that's not the one that you think it's going to be. There's a couple of other shortcuts for this. When you're like selecting on a cell, if you press enter, you will go into editing that cell. And if you press escape, you will go back to being like on that cell. And so you can move around with the up and down arrows. If you press the letter A, it will add a cell. A is for above. And if you press B, it will add a cell below. So those are just a little bit of like the shortcuts of sort of using this. And if you're on a cell and you double press D, so you go DD, you'll delete that particular one. So those are just a couple of useful sort of shortcuts. And so hopefully these ideas of like reading out of lists and dictionaries and indexing into them is something that we've seen before. Defining functions, hopefully everyone's happy with that. We can call these functions now. One thing that Jupyter does is the last item in any particular cell will get output. So you'll see here we've sort of done these 2 additions. If there's something reasonable for Jupyter output after the last line of a particular cell, it will do so. So you'll see that if we do something like this, it will print 5. It runs this add function, but it just sort of throws away the result. And then here, we run this, but it actually prints the result because it's the last line in the cell. We have for loops and while loops, as you've hopefully seen. And here, we can sort of print things there. And we have if statements as well. So, that is just a very quick sort of like, can we establish a baseline Python so that everyone can sort of go from there? Does anyone have any questions on any of that? Otherwise, we will get into the hopefully more interesting stuff. Hopefully this has just been an experience of learning how Jupyter works. Hopefully, and that's sort of given you an idea of how this works. Cool. So, do you have anything to add?
Do you want to mention maybe why we use Jupyter, or like the motivation behind Jupyter?
Okay, so in terms of why we use Jupyter, Jupyter notebooks like this are used pretty extensively at IMC, and I think at a lot of companies, basically because they're really quite easy to sort of prototype with, right? So none of our production code at IMC runs through a Jupyter notebook. It's not like,
That's a slight note.
okay, none of our production code at IMC should run through a Jupyter notebook. But basically, it's sort of the idea that it's really fast to sort of prototype. You can write a little bit of code, save its state, and try something else new. It's really good like that. And essentially, it's sort of mainly used in a prototyping fashion. And it's used by a lot by the traders who are less experienced sort of software developers.
Because
Yeah.
well, I was just gonna say, like, hopefully, like you've been able to see here, it's easy to run like a small block of code, like a little cell, and that's where you can prototype and like write over it. The other thing as well is it's like really easy to share. So like, well, if we hadn't had the link blocking issue, like hopefully you guys can see that this is like we've been able to share this code with you quite easily, and the environment is all set up. So like we're using some external packages, and like you guys shouldn't have to deal with that. So that's kind of the big advantage of. Like the other big advantage is it's just super easy to share and make sure everybody has like a consistent environment.
Yeah. Cool. So let's check my notes to see if I wasn't supposed to say something else. Yeah, that's all just talking about Python stuff, which hopefully everyone is relatively confident with.
So if everybody now wants to flick over to the pandas one,
Yeah.
so like in your sidebar, if you just want to show them.
Oh yeah, in your sidebar, you should be able to, probably should. So in here, there's sort of the Python workshop. We'll be basically exclusively going from the intermediate one. The intermediate one and the advanced one are the same. So feel free to, if you think you're advanced, click on the advanced one.
Or if you want to feel good about yourself.
If you're feeling advanced, you can click the advanced one, but you won't. It
will
won't
be the
change
exact same
anything.
content. Yeah.
But maybe it'll change your attitude, you know? Cool. So, basically, we sort of have this idea that Python is used a lot in data science. And there's some really sort of general reasons for this. This is not IMC specific. This is sort of outside of that as well. It's very flexible and general purpose. It's really fast for prototyping. So like, we can sort of write a little bit of code and run it. One thing that you'll find about Python is like a hello world script is way shorter than it is in like Java, if you've ever written one there. It's, yeah. It's fast enough at runtime when it matters if you really need it to be. Obviously, if you need something to be incredibly fast, Python's not your best tool, but it's good enough in most situations that its ease of prototyping and its ease of use is sort of good enough, like it's like worth it. And it has a really good data science ecosystem. It's got a lot of really good tools. Because people use it for data science, it becomes good at being used for data science because people use it and so on. And one of those things that's really good is this Python library called pandas. And it's used a lot for data analysis and manipulation. So it's pretty similar in a lot of ways to a lot of what you'll find in like Excel and a bunch of other things like MATLAB, but it also has all the benefits of being Python. And we like Python. Yep, at IMC we use pandas every day. That is me. I touch this stuff pretty much all the time. Here, there's also a little bit of a cheat sheet if you want to access it, but a lot of it won't be sort of necessary for today's stuff, but it might be useful.
Feel free to have it on hand if you're like having trouble with any of the exercises.
Yeah. Feel free to sort of come back to that and have a look if you want to. Cool. So, the key thing in jump in.
I was just going to say, like, on the whole Python pandas point, so like, yeah, a lot of people, like, they assume we're a high-frequency trading firm, like, we use, like, pure C, like, the fastest thing possible. But it's really important to understand, like, with HFT, that it's not always, like, not everything needs to be fast, right? Like, you have your things that need to be really fast, like your exchange connectivity, but stuff like Python, what we get out of the ergonomics and how easy it is to code, like, more than makes up for how slow it is, right? So I just kind of want to emphasize the point that it's not always about how fast the program runs. Like, you get a lot out of usability. And also, like, also on the pandas point, like, it's hard to state. Like, I think Pandas is probably like the most popular Python package. Like, this,
Yeah, that number.
yeah, like it's used everywhere. So like, this is actually like super useful just to know in general if you want like any job anywhere associated where you might be doing like data analytics. Like, this is a really good thing to know. So yeah, cool.
So the main thing that we have in Pandas is this idea of a data frame, which is essentially just a table of data. And so one of the things that we can do is we can read these from files. So for example, we can sort of run this and we can get a data frame. And a data frame looks something like this. You'll see that this particular one has 10,000 rows. It prints slightly fewer than that, which is nice. It's a little bit easier to read. But this particular one, we sort of have this index, which is based on the time, and then we have a bunch of these different columns, and these all represent some sort of trades that have happened somewhere. So what we might want to do here is we've had a day here, right? These have all occurred on the same day from 8 a.m. till about 5:30 p.m. and a bunch of trades have happened over this day. Now we might want to look at what's happened and try to work out sort of some things that have happened, some things that have gone on, some trends within that, and then actually sort of look at that and like maybe there's some sort of information that we can gather from this that will be useful in the future. So data frames are column oriented rather than row oriented, which basically just means that a data frame, so a series in Pandas is just like a data frame, but it only has one column. And that one column is essentially implemented just as a single array. And that just means that it sits in memory as like one single chunk. And that basically just means that we have these sort of fancy arrays and they're as the columns. We also have this index over here, which we can use to efficiently look up rows in the data frame. This particular one has what's called a date time index because our data is a time series and all of these values here are date times. So we can have a look at the index by taking our data frame and doing a dot index on it. And you'll see that the result of this is just one of these datetime indexes. Feel free as I'm sort of going through this to sort of work through it and do the shift enter and sort of see everything pop up in front of you as well. So we sort of have this idea of an index. In this particular one, we have this as a datetime index, but maybe we don't really want to do that. So what we can do is we can call something like reset index. And if we call reset index, you'll see what happens is it's moved our time from being, our time was originally in our index, but it's moved it now to be just one of the columns, which is something that we will sometimes do. And if we look at the index of this new data frame that we've created, it's simply going to say that it's some sort of range index. So here, instead of printing out allocating a whole section of memory, 10,000 things long, and then putting 0, 1, 2, 3, 4, 5, 6 in all of them, it just sort of has an idea for doing that, which we call a range index. So we can also have a look at all of the names of the different columns. And we can have a look at the data types of each of the different columns. So if we look up here, I'm just going to clear this output so that things are a little bit closer together. But if we look at this guy here and we look at the price column, you'll see that that goes to quite a number of different decimal places. So we'll see that the type of that is a float. We have the seller and buyer are both just names, which we have as objects, which are just strings. And then we have the book is what's known as a category. Why do we think this book might be a category rather than just a string? Any ideas? Yep.
Because we have specific numbers of categories, like specific categories.
Yeah.
These can be any string basically.
Yeah, awesome. So why might it be preferable to do a category? If in this particular one, we've only got 3. We have pork, ham, and bacon. I believe that the 3 of them. So why might we want to save this as some sort of category rather than a string? Yeah.
Filtering.
Yeah. Yeah, it's just going to save us a lot of space. If we can just allocate each of those to like 1, 2, and 3, as opposed to having to put these full same strings everywhere, we're going to sort of save a bit of space.
Because actually, if you think of the way that like this might be represented like in the physical computer hardware, if you have like an object which is a string, you have to like hold like all, I don't know, 5 characters or whatever everywhere. But what we do when we have categories is like each one is saved as just a single number, and then somewhere else we have like a lookup table that is like number 1 is ham, right? So all we have to store is a single number instead of like a whole list of characters. If that.
Yeah. And then for our volume, we have an int 64, which is just this guy here. Volumes are always going to be integers because you can't really trade half a stock. Cool. So that's a little bit of a sort of summary of that. Feel free to interrupt at any point in time to sort of get on me. This will become a lot more interactive quite soon. We're just sort of establishing a baseline understanding of a few different things at the moment. Cool. So what we can do now is we have our data frame, and we might want to get a specific column of this. So if we want to get a specific column, we can just provide the name of that column, and it will look it up, and we'll get back simply this. And you'll see that this guy now is what's known as like the pandas series, because it's only got 1 column in it. We can also access multiple columns, and we can do that by passing a list of the names of the columns that we want to get. So if we want to get the price, the buyer, and the seller, we can do that. And maybe we also want to get the volume, and we can add that. But at this point, I feel like we're getting dangerously close to just what we started with. But yeah, cool. So we can do that.
Should be worth pointing out, notice that like the double set of brackets, right?
Yeah.
So like, remember we're passing this in a list of columns that we want, unlike just passing in a single one, which is like, that's a common mistake people will make where they'll just forget the extra set of brackets.
Yeah.
Like from experience.
Yeah, so that's like this inside set of brackets is forming a list, and then the outside set of brackets is an index into the data frame. Cool. We can also get our dimensions with a thing called shape, which is telling us that we have 10,260 rows and 5 columns. We can also get the start of the table with a thing called head, and we can get the tail with a thing called tail. So this sort of provides us what's at the start and what's at the end. We can also have this idea of transposing. What do we think this does?
Rows or columns.
Yeah, switches the rows and the columns. Do you reckon what happens at the end of this is that we end up going through the whole thing and changing every single bit of memory to going from rows to columns? Or do you reckon it does something slightly smarter than that?
Wow, which one would it be, Luke?
Yeah, basically what it's going to do is it won't actually go through and iterate over every single item in your huge data frame and change it. It'll just provide like a nice little view on top of that, which is kind of nice that the transpose is at least a little bit smart.
I guess that's kind of the theme of pandas in general, right? Like it's all about dealing with big data, so a lot of the time we don't want to be doing all these expensive operations where we're like copying and changing around all our data, right? We want to provide a smart layer on top of it that lets you aggregate and kind of change and manipulate how you view it, but it's all about being like efficient under the hood with the actual storage.
Yeah. Cool. And then you'll see that this transpose has printed out like that, as we sort of suspected. Cool. And also we can sort of look at, we can combine these things. So once you sort of do this, we can apply the head 3, which takes the first 3, and then also transpose it. So you can start doing this composition of operations. So you can sort of hand a data frame in. So what sort of happens here is we pass in df, which is a data frame, to head. It hands us back a data frame, and then we plug the data frame back into the transpose. Cool. And also we can get a number of summary statistics. This one's actually very nice and useful. It'll tell you like the count of a bunch of different things, the mean can have our price. And sometimes not only do you want to know what the maximum value is, you want to know where the maximum value is. So we also have these IDX max, which is provide me the index of the value that has the maximum thing. And so we know that the maximum price over this whole day was at 9.53. Yeah, cool. So that has been like a quick summary, because I think a lot of that is just establishing sort of some of the ideas that Pandas has before we get into things that are a little bit more interesting. But did anyone have any questions on any of that? Cool. So now we want to get to the point where we can actually start looking into this data frame and doing something slightly interesting with it. So what we might have here is we might have this idea that we want to search through and we want to find all of the trades that have happened where the price is greater than 174 and the volume is greater than 100. So let's break this apart a little bit into some different components. So this is what we're going to end up sort of with. But let's start and let's break out just a little bit of this. So let's look what happens. So we know that if we do our DF of price, we end up with just a sort of series of those particular values. So we see here that it says greater than 174. So let's see what happens once we add that. Cool. So what we've got now is we've got a big long list of things that are true and false values. So now we have a big long list of true and false, and the places which is true is where the price is greater than 174, and the places where it's false is where that is not true. So now that we have this big long list, what we want to do is we want to get all of the things in the original data frame where this condition is true. And Pandas does this really nicely in that we can just index into the original array and hand it our list of trues and falses. So once we do that and we execute this, it's only going to leave us the columns where this sort of other array has been true. So we can end up with that guy there. And you'll see for all of these ones that's left, our values are greater than 174, and I'll promise that all of the rest are also like that. And you'll see that this has significantly reduced the size of our data frame. So now we only have 3,000 rows as opposed to 10,000. Cool. Then we'll also, so now we also want to have the volume greater than 100. So we have this idea that we want to have our price is greater than 174, and we also want to have this idea that our volume is greater than 100. So now we want to sort of combine these two things, and what we normally would do in Python is we would chuck brackets around these guys, and what do you think we would normally put in here? We would normally put an AND in here. Any ideas of what's going to happen if I do this?
The price is above 174, the volume is above 100.
Yep, that's what we want it to do, but instead it's going to get very mad at me. And it's going to say that the truth value of a series is ambiguous. Does anyone kind of have any idea what that might be telling us? It's a very cryptic error message that you get from this particular one. Yeah?
You don't have a single true or false value, you have many?
Yes, you have many. That's kind of the problem, because AND is used to dealing with stuff like this. So we don't have something like that. We actually have these two long arrays of true and false values. And so what we need to do instead is we can use what's known as a bitwise operator, which is just the symbol AND. And this is actually going to look at those particular things, and Pandas knows how to use the AND symbol in the way that we would sort of expect it to. So if we do this, we'll end up with, again, a list of all of these falses and trues. And then what we want to do is we want to index into our original array where all of those things are true. And we end up with this, and you'll see that there are actually only 197 rows for which this is true. So there's only 197 big volume, high price trades in this particular, out of all of these 10,000. So maybe if you're looking through and wanting to do some analysis, these are the ones that are really interesting to you because they're the biggest trades that have happened. Cool. So that's just breaking down essentially what this line of code means and how it sort of processes. So we can delete that guy and we can run this one. Cool. So we end up with that, like that. Awesome. Any questions on that? So we're starting to get into things that actually look genuinely useful, which is kind of nice. Now what we can have a look at is, well, maybe based on all of the things that we've seen so far, maybe we're interested in creating a new column based on all of the things that we already have. So what we can do is we can create what's known as a projection, which is basically just a fancy word for a new column. And we can make use of sort of some of these other functions that we like, sort of like our min and our max that we saw before. Now, what we're doing here is, if we take our price and we apply this round -1, what do we think round -1 is going to do? What do we reckon round 0 does?
Round to the whole number.
Yep, round to the nearest whole number. What do we reckon round 1 does?
1 decimal place.
1 decimal place. So what do we reckon round -1 does?
Nearest 10.
Nearest tens. Yes, cool. So pretty much all of the functions in sort of pandas are kind of exactly what you expect them to be. So like there's one that's called min, and it provides you with the minimum value, and there's one that's called round, and it rounds it to the nearest value. Like they're kind of what you sort of expect them to sort of be. So we get this thing, and we can round it to -1. One of the things that's a little bit annoying after all of this is that we end up with like 250 and 90.0 because they're still floats. And then the idea is that, well, all of them are going to be multiples of 10, so they're all going to be ints anyway. So what we want to do is we just want to make sure that they actually are ints. And we'll do this as type int. And sort of apply that, and we'll get to something like that, which is quite nice. Now, so we have this, and this now returns us a series. And what we're trying to do here is we actually set that series to be one of the rows, one of the columns of our original data frame. So what we can do now is we assign that to our approx price, and we can run this code now, and you'll see that the approx price column looks like this. But if we now look back at our original data frame, we've sort of added this guy to the end. So now we have a bit more stuff. So what you can do is you can imagine that there might be a few of these, and you can sort of slowly accumulate them and then compare them and do things like that, and you'll sort of get to now things that are a bit more interesting than the original data frame. Cool. We also have this idea of dot apply, which is the idea of you sort of have this column and you go through every single item and you apply some sort of function to it. So what this is going to do is it's going to go through, we get df book, which is just getting a single series, and then we apply each of those values through this function. And what this function is going to do is it's going to replace a with x. So we can do this, and you'll see that all of our ham has become hxmm. So there's a couple of interesting things to note about this. After doing this, what do we reckon the original data frame, if I print it, will have? Do we reckon it will have ham with an A or ham with an X? Oh, this is a contentious issue. I'm glad I asked it as a question. All right, let's have a look. At least someone in the crowd said the correct answer. Oh, the slow reveal. it's still got the original one. So pretty much all of these operations that you sort of apply on data frames will return new data frames. They very rarely edit the original ones unless you start doing stuff like this, where you index into the original array. So this edits the original array, but this does not, because it's sort of applying something and returning it. So that's just sort of a thing to be quite careful about when you do this. A lot of the time what you'll sort of want to do is like apply something and apply it back to a new variable. Any ideas? This is getting quite deep into sort of things. But any ideas whether or not the apply function is something that we want to do regularly or not want to do regularly? This apply function either exists in my code a lot or doesn't exist in my code almost at all. So, which one of those two do we think that it is?
It depends on the complexity of what you want to do. Because most of the things are like standard stuff. If a non-standard operation, you want to go into a function.
If it's possible to do something without apply, should I do it without apply? Any ideas why that might be true?
Why might apply be slow?
Why might apply be slow? The problem is that it's slow. Yeah?
So all the basic functions would be optimized to do it like in parallel, where apply would do it one by one, I'm assuming?
Yep, that's basically correct. The idea being that pandas under the hood is implemented a lot in C. So if you do its basic operations, it hands it down and does it in C. Whereas this apply function has to go and read this function in Python. So it has to do every single step one by one in Python. Whereas all of these other things that we've been doing before, hand it down a little bit deeper and all of it's done in C, and then it comes back up and it's really fast. So just as like a general sort of idea, apply, not my favorite function. We avoid it as much as physically possible. Again, occasionally if you have something really complicated to do, you won't be able to avoid it, but that's just a little bit of a side note. Cool. So we now actually get to the stage where we're doing things that are interactive, because hopefully we've taught you enough to sort of get going on a few things. So we're going to get to this idea of group by in a little bit. But what I want you to have a go at first is to try to use the things that we've covered so far and your general Python skills that we covered in the first section to try to do all of these different steps. So what we want you to do is to find all of the unique books, and for each book find the max price, store each max price in a dictionary, and print the resulting dictionary. So we'll give everyone a little bit of time to sort of go through that, and we'll sort of go for a little bit of a walk around and sort of answer if you have any questions about anything that's sort of covered up until this point. But I'll give everyone a couple of minutes to have a go at that. relatively quickly, just so that we can sort of make sure that people get pizza on time, because otherwise I think my head may be on a steak. So, cool. Any ideas how we would go about doing this? Where would we start? How do we do step one? Let's go with step one. Yep, cool. So we've got find all the unique books. So we've got our data frame, we can get our book in it. And I might actually just quickly jump out to a different thing so that we can look at it. So, and we can do our .unique that we saw before. So we'll get each of these guys like that. So now we can sort of set that our books are just these unique values. Awesome. So for each unique book, what we want to do is we want to find the max price. So how might we go through each unique book? For loop? Yep. So now that we've got those, we can sort of do for our book in books. And how do we find our unique, how do we find the maximum price of that book? Yep, cool. So firstly, we need to make sure that we only get the books that have that name. So what we can do is we learned before that we can say these are the ones where our book is equal to our name. And now that we've sort of got that, we will want to save that somewhere. So we'll save that to say, what if we did that? What?
Rather than name?
Yes, correct. That is well spotted. That was a trap to make sure you guys were paying attention, and you are. Well done. Well done. Anyone got any potential problems that will happen if I write this code here? Yeah, so the problem with this one is I'm reassigning this result back into my variable df, and after that, it's just all going to, I've now lost my df that had everything in it, and then I'm going to be looking for the other books where they've already been removed and things like that. So we'll just say this is some other stuff, we'll just call it this book, and then what we want to do is we want to get the maximum value of that, so we can get this. Classic. And then we want to do that this is our max. And then we want to just add that to a dictionary. Cool. So I might just chuck all of this stuff in here. And we want to add that to our dictionary. So we want our max prices of our book to be assigned to this value max. This is really not very Pythonic code. This is all sort of stuff that we can do in only one line. So what we could do realistically is we can sort of chain these things together. So we can take that guy, we can take the max of it, and then we can assign that into our book. Cool. So, and then we can print this max prices, and what we've got here is, what did I do wrong? I purposefully did something wrong here. That was, yeah, we want to filter by the price column, so essentially we've hit the max value in all of them at the same time. So once we do this filtering like here, we've sort of got all of the columns which are that book, and then we just want to take those ones that have the price. Cool, so looks like bacon is more expensive than both pork and ham. So, I mean, the more you know. Cool. So this is a little bit clunky code, having to go and write a for loop over all of this stuff. That's very Python. This means that we have to do for loop in Python, just like with the apply. We want to do for loop in C. So we have this idea of group by. And one thing that's really nice about Jupyter is we also have this idea of a question mark that you can pass after a particular function. And if you run that, you'll actually get the signature for that function and all of sort of the doc strings that are associated with it, which can just be really nice. Rather than having to go and look somewhere else for all of the documentation, you can sort of just run this guy. So if you're ever sort of interested in having a look at maybe some of the parameters that we can apply to all of these different functions and things like that, you can chuck this little question mark at the end of it. But that's just a little bit of a side note. We'll get rid of that for now. And I'll give everyone 1 or 2 minutes to have a look at this. We can run this code here, and it's going to give us something. But what we want to do instead is we want to modify the cell to print the max price and volume per book. Whereas this appears to have not done that. That appears to have grouped by the approximate price, taken the volume, and got the mean, which is not what those instructions ask you to do. So have a go at modifying that and see if you can print the max price and volume per book. And feel free to ask any sort of questions. But I'll only give like a minute for this. Did write a bunch of extension questions that are at the bottom of all of this, which you can sort of have a look at. If you're sort of familiar with Pandas to the point where all of this is not particularly, if it's not new to you. So there's a bunch of those which I think in theory get progressively harder. Yeah. Does anyone have an answer for me for this one?
Group by book.
Group by book? Cool.
Index price.
Index the price?
Yep.
Yep, and then
Dot max.
dot max. Cool. If I run that, I get those. Sweet. So what's our opinion on whether or not this is better than this? Which one looks nicer? The second one is, yeah, hopefully that was a fairly easy question. Yeah, this one's way nicer. Sick. Any opinions on that? Anyone got any alternative suggestions? Potentially something missing?
Change the price index to the list containing price and volume.
Yep. So the question was max price and volume. So what we can do is, well, we can add the volume. Have I done anything wrong there? Yep. What have I done wrong? I I need the inside list, right? So we need to pass it a list. So we need the double brackets through that. And then we'll end up with a data frame that has both the price and the volume. Sick. Cool. Awesome. So now let's see if you can we've got a couple more exercises. So we'll sort of spend a little bit of time on each of these. I'll go through a solution and then sort of move on to the next one. But feel free to sort of run ahead if you're crushing it. And there's also a bunch of documentation for group by here, or you can use your cheeky hack of just use a question mark. Cool. So this is sort of asking to write some code to group by more than one column at once. So I have not taught you how to do that. That's something that you'll need to go on an adventure to try to find. Sick. Cool, so I'll give everyone a couple of minutes for that, and then we'll keep going. And to have a look at this, and now we can go about doing it. So what are our ideas for this? Well, I don't know how to do this yet, so we're going to have to look at the documentation. And so that I have the documentation up, I'm going to do my cheeky little trick. So what we want to do is we want to group by more than one column at once. So let's look at this group by function, and let's look at this parameter by. It says a bunch of different things. If by is a function, if a list, that sounds kind of interesting. If a list or ND array of length equal to the selected axis is passed, then the values are used as is to determine the groups. Cool. So what do we think we do?
Pass it a list.
Pass it a list. That seems pretty sensible to me. So what we can do is, and what was the goal of this? We were looking to group by more than one column at once, so book and approx price. So let's try group by our book and our approx price. Cool. So the result of a group by is always this sort of group by object, which is just sort of saying it's some sort of pandas idea that it knows what to do, but just a group by without any sort of aggregate function doesn't really make sense to pandas. Like, you need to say group by and do a min, or you need to do a group by and take a max. Grouping by just things doesn't make sense without that aggregation function. So yeah, cool. So we can do that, and then we can sort of maybe take a min or something for those. Cool. And then we'll sort of see a bunch of these different things. And what happens if we put as index equals false into cool. So let's have a look at group by again and see if we can work out what we expect it to do. So we have this as index guy, and its default value is true. So it's normally true unless we explicitly make it false. And then as index, for aggregated output, return object with group labels as the index. Okay, so as index equals false is effectively SQL style group output. Okay, so let's try that, and instead pass this is index equal false guy in. And what do we expect to have happen?
Oh, you just spelled the parameter. It's as index.
Yep. Again, strategic. I'm good at planting these ones for you guys to catch. What do we expect to have happen?
Flattens it to a table.
Yep. It's just going to make those actually columns. Cool. So that's a bit of an idea of that. Now let's print the max price and volume per unique book. Price. Cool. So what we want to do here is, instead of doing a min, the actual task was to do a max. So I'm going to do that. And then we also only wanted the max price and volume. So when we sort of take this group by, we can then filter it down to our price and our volume. Remember that I'm doing the double one there to say that this guy in here is a list. So that's being passed like that, and then that's just going to filter down and get rid of sort of the seller and buyer columns. And there's a bunch of these nan columns in there because we actually don't have any values for pork that are that high at all, but we're including those columns. And one thing that is very nice in Pandas is you can use this drop NA function, which just drops all of the columns that have nan values. Cool. And then we get something that looks a little bit nicer, which is apparently just short enough to be printed out on this screen. So, and I already above. Cool. So we'll go on to the sort of next exercise pretty quickly. Yeah, do you reckon? I might just jump straight into it. Yeah, since it's 6:30. Cool. So what if we want to use multiple different aggregation functions at the same time? So maybe instead of finding the min and the max separately, we want to find both of them at the same time. And maybe we want to find a mean for another column. So we're going to need to use something a little bit different from what we've been using so far. And so we can look at the docs for the aggregate functions. There's a link there, and again, we can sort of use the aggregate. So we can have a look at this link, which is and then we can have a look at a bunch of the different things in here. So I'll give everyone a couple of minutes just to have a quick look at that and give it a go. Sweet. Yeah.
No, I do.
we want to look at how many entries are in the group, the mean volume per group, and the min and max price per group. So let's have a look at each of these, and we'll have a look at the guy here. So we can pass this what appears to be a function, a string, a list, or a dict. So let's have a look at the first one. So how many entries are in the group? So let's sort of think about that and what that option might be. So we basically just pass it a bunch of different functions, and there's a list of functions and or function names. So if we want to know how many things there are, we can maybe try and count. That seems promising. So amazingly, there's the same amount of price, seller, buyer, book, and volume in each of these different groups, which is good. So that sort of gets us an idea of the entries. Let's have a look at the mean volume per group. So it looks like we can do a list of functions and or function names. So maybe we want to change this to be a list that also has the mean. And we're sort of getting into a bunch of different problems here. And what we might do is just filter down to just the volume before doing those. Cool, so now we've got a count and a mean. But now it also wants to add the min and max price per group. So, any ideas how I might go about doing this? So I've already got the count and the volume mean, but now it wants the min and max price per group. So, any ideas looking at this, what I might be able to change to?
Dictionary.
A dictionary? So, it says that it looks like a dictionary of access labels to functions. Cool. So, this is saying that instead of doing this and filtering first to the volume column, I could actually specify that within this. So I could create a dictionary that maps volume to this list, and we would get to the same sort of thing. But now that we have a dictionary, we can also add the price to it. And for price, we wanted a list, and we wanted the min and the max. Cool. So that sort of got us this guy there, and we've now sort of managed to, in one line, accomplish all of these different things, which the aggregate function has been pretty useful for. Cool. Any questions about that? Sweet. So I'm going to clear this output because I imagine people don't want me to get rid of that off the screen. Awesome. There's an extension there, which is basically that Pandas also lets you write your custom aggregation functions, which is pretty cool. You can write your own one. So say you wanted to take like the product of everything, or maybe some other thing. Maybe you want to take the difference between the maximum and the minimum. That could be something that would be a custom aggregation that isn't one of the sort of basic ones. Cool. So now we have this idea of resampling. So often when we're working with sort of time series data, like what we've seen, we want to perform calculations over specific time windows. So as much as here we've been grouping by things like books, maybe we want to group by 5-minute intervals. And the resampling is a way to sort of do that. So this is similar in spirit to a group by, in that we resample and we pass it something. 1H here just means 1 hour. So what this is doing is we're resampling all our values into 1 hours. We're taking the volume out of that. So this is going to give us back sort of something similar to the group by, in that it'll be one of those iterator things, or Will it? Who knows? Let's find out what the result of that guy is. Yep, so it's this resampler object. And then what we want to do is from that we take our volume. Cool, and that's still going to be this group by thing. The one thing that's changed there is it's changed from a data frame one to a series one because we're only taking one column now, and one column is called a series here. And then we sort of apply this aggregate function over it, which is the sum. And then we can get the sum of all volumes traded in each hour. So you'll see that maybe this last hour here is a little bit of a less exciting hour than all of the rest of them. And that may be because it ends at 5:30. Awesome, so just like group by, we can use resample in pretty much all the same similar ways and use all the same sort of group by things that we did with aggregate functions and mins and maxes and stuff like that. Just instead of grouping by specific values, we're grouping by sort of time periods. Awesome, so let's do this exercise and run through this. So let's have a look at what this is doing. We're grouping by our book, we're filtering down to our volume, we're now resampling 20t, whatever that is, and then sum. So let's run this. What does it look like 20t means?
20 minutes.
20 minutes, cool. Seems like an odd thing to use the letter T. Why wouldn't we use M? Any ideas? Let's give it a go and see what happens. What do we think's happened here? What do we think 20M means?
Milliseconds.
Milliseconds? Alright, let's go back to the T for a second. And I'm going to copy this guy and put it in a new one with the M, and we'll look at the two of them next to each other. Okay, that's the two of them. Any ideas what the M is?
Is it a month?
Yes, it is a month. Why do you think? How have you got to month?
Because it's too big for the single day time period.
Yeah.
And
Yeah, one thing that's a little bit of a cheeky thing here is that this is actually grouped all on the 21st. So all of these things happened on the 21st, and when we did this resample, we managed to move to the 31st. So we actually grouped it all in a month. So that's just a little bit on what T means. Cool, so we're resampling into 20-minute intervals, and then we're doing the sum of all of the volumes in those intervals. So now we're seeing something that's a little bit more interesting in this bacon thing. This bacon book had a lot of trades between at 8:40 in that 20 minutes, but then at 9:20 it had a lot less. So we're sort of like maybe something super exciting happened in that time. From sort of a like trades perspective, this might be something, if we were like experiencing this and like looked at this data and saw something like a lot of trades happening at one time, that's often something like, I don't know, the US president is giving a speech right then and it's all going up and down based on what he says. So things like that, or like a lot of those big macro scale events will sort of cause these times where people are trading a really large amount. Because every single word that comes out, they're like, oh, that means that means the economy's going this direction, and then they go back and forth based on pretty much everything. So this might be something like a big statement is made, and then once that statement's made, it all settles sort of down a little bit. Awesome. Did you want to go through this? Sure. Sick. I'm going to hand off to Matt.
Cool. So, the thing about Pandas is that, like we kind of mentioned earlier, it's all about dealing with a lot of data, right? And so, like, that's why we need Pandas to a certain extent to be fast. So, what we've got here is a little example where we have three different ways of representing a lot of data. So the first is like a row-oriented table in pure Python. So you can see here we literally have a list, and then we create a list of lists, basically. where each item in the list is a row. In the second one, we have a table of columns, where each item in the list is its own column, and then like within those columns you have multiple values. And the last one is like an actual pandas data frame. Does anybody want to think about, especially like between this table of rows and table of columns, like what's going to be more efficient, and like if anybody has any ideas on why that might be? Any thoughts? No thoughts? Head empty? Does anybody want to maybe guess which one will be slowest and which one will be fastest? The fastest one is a bit of a gimme, so
The fastest will be the pandas.
yeah.
He's a smart one.
Yeah.
The slowest will be the bird-oriented table.
And why do you think the row-oriented one will be slowest?
I just see there's a lot of actions happening. There's a random, and there's tutored groups happening there.
That's probably a decent heuristic. Like if there's a lot of stuff going on, it probably is slower. So what we might do is we might just create this, and then we have this handy little timer function. So you can see essentially what we're doing is in the first one we're summing, and then for each of our rows we're getting the fourth value, which is like this fourth column, and then we're summing over all of those. In the second one, we are getting our fourth column, which obviously has a list of all the rows, all the values for that fourth column. And the third one, we're using the actual pandas inbuilt function. So maybe this can kind of, like, going on that whole like complexity idea, give you even more of an idea why the table of columns might be quicker. So we run that. Just give it some time. 144 microseconds for pandas compared to milliseconds for the native Python lists. So that's a big difference, right? Like, it's way faster. But also, like, kind of what we wanted to point out here is you can see the difference between the top one, which is the table of rows, and the second one, which is the table of columns. And so, like, if you look through this function, what we have to do is we have to unpack all of the rows and specifically get out the fourth column out of them. Whereas, like, if we already have it in a columnar format, we only have to, like, select it out once. And so the idea here, and the idea with pandas in general, is that, like, most of the operations that you'll end up wanting to do on data, you end up wanting to operate on the whole column, right? You want to operate on it all at once. So that's why it's so much more useful to have everything like grouped by columns instead of grouping things by rows, if that makes sense to everybody. And like you can see the results here, right? Where we're just so much faster. First of all with just rows, and then once we actually get into pandas where it's doing these native C operations where it can be so much faster.
So there's a question at the bottom there, which is basically, if we made this a lot smaller, what do we think would be the actual comparison between these again? So currently we have something that's like, what, 100,000 rows long? What if that was only like a very small thing that's like 10 by 10? Which, do we reckon that pandas would still crush the other ones, or what do we reckon?
It'll still be slightly faster, but not crush.
Slightly faster, but not crush. All right. Any other opinions?
It's going to be slower because the calls to C take longer to start the C code and bring it back up for a very small amount of rows. Doing it over a big set, then you sort of get back to being efficient.
All right, we've got two different opinions there. Let's give it a run. Let's give it a whirl. It's a really good way to build suspense this time. That's already a lot faster than last time, but that's kind of expected considering it's a lot smaller.
Well,
So which one was faster?
Python.
Yep, Python was faster than C. As we heard over there, every time we there's a little bit of overhead associated with this idea of handing it to C and getting it back from C. And if you're doing all of that overhead just to sum up 10 numbers, like Python probably could have just summed up the 10 numbers, right? Is sort of what this is sort of saying here, is that if it's something that's super simple, like the whole overhead of like doing the C thing and everything doesn't really help that much. If anything, it hinders. But if we start sort of having something that's really big, which are the ones where we actually care how fast it runs, because all of these run so fast that it's just easy, then Pandas sort of comes into its own. Cool. So, I think that's pretty much everything we had in terms of like presentation stuff. Hopefully this is aligned relatively well with the arrival of pizzas, although I don't see them just yet, so I can stall and continue talking for a little bit.
Do you want to add a code gem as well? And
yeah, so there are a couple of extension questions here, which are sort of starting to become things that are actually kind of interesting. So what you can sort of see is this is starting to getting like, oh, what was the 5-minute period where sort of there was the biggest change in price? That might be the point of time in day which is most interesting to us, is the one that saw the biggest shifts. And we sort of then would be like, okay, why is this sort of happening there? And then we can start looking at individual users and being like, well, Alice keeps making all these trades. Is Alice making any money? Which is pretty good for like competitor analysis. So we want to know whether or not our competitors are making money, and also whether or not we're making money. Both of those are things that are of interest to us, probably the latter even more interesting. And then yeah, so what you can sort of do is you can start looking at all of these things and using Pandas to go through and actually work out sort of, in this case, who won, who did well on this market, who was sort of making money and who lost money, and things like that. So yeah, we've still got a little bit of time, so feel free to sort of go through that. Otherwise, if anyone sort of has any sort of general questions or anything like that, it's a pretty good chance to sort of ask them. Otherwise, we will be hanging around and mingling and stuff like that. It's a good chance to sort of chat to some people and things like that, so that'll be nice.
Awesome. Well, thank you very much, IMC, for coming out today. So on behalf of everyone, we'd just love to thank you guys for presenting with some Math Black limited edition UQCS mugs.
Damn, I feel honored. Thank you.
Enjoy that.
Cheers.
And yeah, so yeah. Sorry, my bad. So yeah, so as you guys may also be aware, IMC will be sticking around on Saturday for our Code Jam. So if you haven't got tickets for that already, make sure you do get some. Because yeah, it's going to be a very big event, plenty of programming questions to go around so that you can practice your skills, practice some of this to some extent as well, so your Python knowledge. And then obviously further along down the track, we've also got our competitive programming group, which we will be launching again on Wednesday next week. So yeah, plenty to look forward to with UQCS. Hopefully pizza will arrive soon. It was meant to arrive like 10 minutes ago, but anyway. So yeah, just hang around, but thanks for coming today.
This is a very nice one.
It is.
You guys brand well.